Okay guys, so we're back with still more exercises from activity 5.4. I wanted to do 2 more problems to show you of solving rational equations. And then I wanted to come back and just touch on horizontal asymptotes since I kind of skipped over what they covered in the activity there because I think I can give you a little more information that they're giving about how to find them. So I have this example. This came from page 518 and it's 3b. Just to solve this rational equation. So I just want to step you through it a couple more times. So our goal is to try to get this denominator right here. We want to get this really out of the denominator so that we can start solving. So what we end up doing is we multiply really the entire equation, both sides. I'm going to erase this for right now. So let's get this out of the way. Whoops. Guess I can't erase that if I did that ahead of time. So just ignore that number 1 there. I'm just going to kind of show you that I'm going to multiply both sides of this by 5x minus 3. That's in the numerator. So that the 5x minus 3 and the 5x minus 3 on that left side cancel to 1. So I really have x plus 1 equals, and then over here I'll distribute. I'll get 10x minus 6. And that was really the point of what we just did, is to now we have a nice linear equation that we can solve. So what we end up doing is we bring over our x's. At the same time, I'm just going to bring over my values to the other side so that those drop. I get 7 equals 9x. Those drop. I divide by 9. I get x equals 7/9. Okay, so whether or not, leaving it in fraction form is perfect, because if I make it to a decimal, I have to round. But, you guys know that if you're in my math lab and they ask to round, that you'll do that. So let's look at another one. So this one, same page 518, I got this one from. So I'm trying to get the x that's in the denominator out of there so I can solve. So I'm going to multiply by this denominator on this side. And I'm going to do it on the other side as well. So I'm just going to stick it right there. But remember, that's in the numerator right there. So these drop out. So I have negative 7x equals, and then I have to distribute this out to 8.68 when I distribute that, plus 3.1x. So I'm going to bring this over here. Whoops. You know what? Let me get rid of that. Actually, that's not what I wanted to do. Sorry about that. I'm going to end up bringing this one over here. I thought the other one had an x on it for a second. Okay, so those drop out. I end up with negative 10.1x equals my constant. I divide out the 10.1, I get x to be, now this one started out in decimals, so I'm going to leave everything in decimals because that makes sense. So I get a negative 0.859 when I divide out that 10.1. So hopefully those 2 examples just, give you a couple more problems to look at when you're doing your homework. So I wanted to come back to this. I looked at this in 5.1 and 5.3, looking at the graphs. And the reason I skipped over it when they went back to it in 5.4 is because they didn't give you any more information. They just kept having you look at the graph to see where the horizontal asymptote is. And we certainly can do that. But I can actually look at the equation and find the horizontal asymptote right in there. Okay, so and all the ones in this book, this falls true for, if the top degree equals the bottom degree. Okay, so let me describe what I mean there. Okay, so the top degree function here, 3x plus 1, this is a degree 1. This is a first degree because x is to the first. That's the highest power. This is also a first degree. So when they're the same degree, when both the top and the bottom are the same degree, your horizontal asymptote comes from the coefficients of those leading terms. Okay, so this really has a 1 in front of it. So my horizontal asymptote is the equation y equals 3 over 1. It's the coefficient of the x terms, the highest x term. And that only works if, what we say right here, if the top degree and the bottom degree are the same. So if the top degree was an x to the first and the bottom degree was an x to the second, this wouldn't work. You would talk about that more in a college algebra class. But for now, all the ones they're asking you to find the horizontal asymptote, they are equal on top and bottom. So let's say I wanted on this one, I wanted my horizontal asymptote. Well, the top is its first degree and so is the bottom. So I want my coefficients. So this really is a 1. So this will be the line y equals 1/2. So over time, as x goes off to infinity, this graph will approach y equals 1/2. You can always check this graphically, but I wanted you to be able to find it without always using the calculator. Let's just quick review for this first one. I'm going back to this first one. The vertical asymptote, this is undefined if x is 4, because that gives us a 0 on the bottom. So it would have a vertical asymptote at 4. And this one right here, my vertical asymptote, this would be undefined if x were 2. So I would have a vertical asymptote at x equals 2. Okay, so hopefully that helps you find the equations for the asymptotes without always having to rely on the graph.